Hello and welcome to another video. Today we have an MSI B550M-A PRO on our bench. That looks very like that looks someone has tried to replace the socket around it. And how I can tell is if you have a look right there, let's get the ring light off of here. B550M-A PRO, and the sticker is a little bit blown up. And you can see some marks around the socket right here, that there probably was someone that has tried to clean something off that was around the socket. For this board, before I do anything, I want to start and see if this has a dead socket, that maybe someone has tried to replace the socket or reflow the socket or do anything with it, and we actually have a damaged one and it didn't work. For that, we use a DDR tester, DDR data line tester, because if a socket is badly soldered in place, we will have broken connections for the DDR sockets. But in this case, let's get the light out of here at all. In this case, we seem to have good connections all around, except, no, that is just a little bit of wiggle room. Yeah, those connections look good. And not is only the DDR a good indication for if the socket is soldered in well, but the PCIe is also a very good indication. So the main PCIe slot can be tested with a tester like this that needs 12 volts at its input. So let me get the power supply, get 12 volts onto here. See, now we have 12 volts now connected. And if we now flip the board up and press the button, we can see all of these LEDs on, which means all of the PCIe has good contact. The in the bottom right shouldn't be on, but all of these are connected. So that is a good sign. So I don't think that we will have a problem with the socket. So the socket is probably fine for us. So we do not need to worry about that, because the socket just looked bad and I wanted to check at the beginning if this video might even not be worth it to start. So yeah, with having that checked off of the list, let's go for some resistances of this board now. So let's see if our multimeter shows 0 when we touch the probes. Yeah, we see 0, that is 0 volts, but we want ohms. That shows 0 ohms basically, that is good. What we do now, we get a ground. Let's take it from the DVI connector right there. And let's now start at the 24-pin connector. Get some more light in here. Get at the 24-pin connector. So let's see. We start with the 3.3 volts in the bottom left right here. We see high resistance, kilo ohms. This is the 5 VSB, 4th pin from the top left. 800 ohms might be okay. 12 volts auxiliary, kilo ohms and rising. The 5 volts. 320 ohms, low, but could be fine. So the 5 volts is the second pin from the top right, 12 volts is the second pin from the top left, 4th pin from the top left is 5 VSB, bottom left pin 3.3 volts, that I always check. Then we go over to this point right here. This is the auxiliary 12 volts for the CPU, and this has high resistance. Just go into both of the pins. And then what we do then is we take the upper one where the notch is on that side, take a pin of that and check the inductors to see that we don't have a short circuit through the MOSFETs into the CPU. So that is all fine. What we now can also do is we see some of these inductors, and these inductors are always very easy to probe at the beginning. So we just get a ground and go on some of these inductors, and this inductor right now is very low already. Let's see. 44 ohms. That seems, if that isn't PCH, that seems very low. Okay, let's check some more. So let's check this inductor right here. 300 ohms. That looks already a little bit better. This little inductor here shows kilo ohms and rising. This inductor right here shows kilo ohms. Then there's another inductor closer to the PCH right there. And another inductor right here. And this is probably the PCH, which is why we see low resistance for the B550 one. Yeah, 16, 15 ohms. But that is probably fine. Let's see around the SIO. Just some capacitors, but they have high resistance. That is good. So I'm really interested in this resistance right here. This is only 44 ohms. Let's go under the microscope and check that, because I can see some discoloration. There might be a short capacitor or something similar to them. So let's go under the microscope and check this inductor. But before that, let me thank today's video sponsor, who is, as always, PCBWay, in our case, who helps us to get very nicely printed and very high quality PCBs. You can see two of the PCBs that I managed to design and get with their help. This is for these boxes right here. These are my current sensing boxes that you can get that have the full PCB inside of there. And this is the bare PCB. And this is the switch panel box that I made right here, that I'm using to switch different loads on my workbench from an ATX power supply, where it just takes a few inputs through some switches and puts them to a few outputs. And this is like what a version looks like, where the switches are fitted and it had been in use already. And yeah, I want to thank PCBWay very much for sponsoring this channel. If you want PCBs printed, go there. They have great offers. Most of the boards you can get within a week of uploading the files and purchasing them. They get within a week at your place. And yeah, they also do 3D printing, sheet metal fabrication, and many more different things. But yeah, I had great experience with them as always. I can only recommend them. And thank you, PCB, for sponsoring us. So this is our output where we had some problems. Oh, I can see something there also happened. Oh, yeah. Okay, so what I was worried about is the 44 ohms that we have on this inductor right here. And what I can see is that that resistor right there is broken. I only wanted to have a look at this here, at this output, and I would guess that maybe one of these capacitors is actually shorted. Let's see here, 44 ohms, yeah. Okay, we will have to see what this line is. This line is probably like 1.8 volts or something like that. And for what value that resistor is supposed to be, that was here or partially was here. And yeah, and then go from there. We probably will have to inject some voltage and see under the thermal camera if any of these capacitors here heat up when we do that. And also check for that value. So let's go over to the PC and do that. So now we are in the board view. Let's have a look right here. We have R203. This is a 10 ohm resistor, 0603. And 1%. Okay, so we need a 10 ohm resistor for whatever this is. Okay, this thing takes VPP power good and similar things, so this is mostly responsible for VPP. And this is for the bootstrapping, so this will definitely not work, the VPP, if this resistor isn't in place. So that will have definitely prevented our board from starting up. And what is this? This is VDDP. Oh, this is CPU VDDP. And I measured with the CPU in there. That's probably why we have that lower for resistance. So we need a 10 ohm resistor right there. And we need to see if this resistance goes high as soon as we take out the CPU. That is probably the case. So just very quick of going into the board view. Let's go to the board once more then. Just to check again, we see 44 ohms right there. And now let me unplug this CPU. And now let's check again right here. Yeah, now we have high resistance. That is such a rookie mistake by me. Like measuring CPU voltages when you have a CPU in there, CPU resistances when you have a CPU in there is often just not good because you get low readings like that, and now we have 3 kilo ohms. So that is probably fine, but we got really lucky, and this led us actually to look into this direction to see this 10 ohm resistor and find that that is broken. But if one thing is broken, there very often can be other things broken as well. I'm not sure if this BIOS chip was touched before, if someone has flashed the BIOS on here. Let's, just to be sure, look for some more damage around the board, because visual inspection is very important and can lead you to results like this. Things I would check is always around the mounting holes for the cooler, so just around the PCB of the CPU socket where the cooler mounts, you need to have a good look. Then where the PWM controller is, there could often be damage. In this case, it looks fine because there's a lot of passive components here. Then go to the 12 pin, but the 12 volt CPU connection seems to be fine. Let's then go around the BIOS we already were. And then you can also always look around M.2 connections. So in this case, you have the M.2 right here. And you need to look at connections there close to there then also. And everything that is in the path of that M.2. Then also at the edges of the board. Like in this case where the SIO often sits. But in here it's only the audio controller that sits there. Then you can also check close to PCIe slots, especially around the SIO, to see if there's any damage. But this looks also to be fine. And around power buttons, you can also have a good look. There's sometimes broken off components. And at the PCIe latches, right here, for example, that people try with a screwdriver and then damage stuff around there. But in this case, everything looks very fine. Like, if you have one spot of damage, like we saw at the VPP, you very often have more than just one. Like, people very often then are just in general not careful with their boards and then damage multiple things. But in this case, it seems to be only that one place. Let's check the backside. If it, yeah, the backside has some components, so there's a little bit to check here. So right here, for example, but this looks very fine. No damage here. Let's see right here, no capacitors ripped off, no resistors ripped off. At the back of the VRM, some 2.2 ohm resistors, but they look to be fine as well. 0 ohm, also looking fine. Let's see here behind the PCH, behind the chipset. Nothing broken off, nothing damaged. That looks very good. So yeah, then let's just go ahead, find a 10 ohm resistor and replace that one there. Because it might actually be, we didn't turn the board on now, but we really don't need to, because this will prevent our board from booting up. We got lucky to find this. So let's take a soldering iron, get rid of the old resistor here. Like that. Old resistor is out. Let's clean up the pads where it connected. Have a good amount of leaded solder on there that is clean. And let me get a 10 ohm resistor. So I found 10 ohm resistors. 0603, I think these are. This might be 0402, but I think it's 0603. So it will actually be the proper size for this. If this is not 1206, but I think it should be. Yeah, this looks very good. I think this is the right size that we need here. Let's see, and the markings also are the ones that we had before. 0, 1x. That is very good. So let's get it into place. Let's get our soldering iron here. And solder on this resistor. There. And this side also. And what I always like to do, as soon as I replaced resistors or capacitors or any SMD component like that, I like to give it a quick reflow, just to be sure that it's connected properly. Just like that. And now we are 100% sure that the area or that the resistor is properly in place. And what we can do now, let's get some of the cleaning sponges. So now while everything is hot, let's clean up the area. Get the sponge, get all of the flux off of here, that it will look nice and good. And also turning around the sponge a little bit, so that we use all of its phases, that it can suck up more flux. And now you can also just quick dry this with getting a little bit of hot air. And now it's looking all fine. As you can see, I can recommend these sponges a lot. This is more the area that didn't get cleaned. And this is how the area looks like that did get cleaned. So yeah, these I can definitely recommend for cleaning. So let's go into the overview then again. So we didn't have, we don't really know how the board behaved before, but I can pretty well tell you that this board probably wouldn't have booted up because the VPP had problems. So let's get a 3000G into here. Hopefully that is supported by this platform, or by this chipset in this case. Let's get a stick of RAM into here. Then get our 24-pin adapter into here. Get a speaker and a power button onto here. Let's be optimistic and already plug a post screen into here. Let's get a keyboard also onto here. Let's zoom down a little bit. Does this? Yeah, this has some LEDs right there. So let's see for its passive power consumption then. That is not right. 250 milliamps. That is a little bit high. That seems like something is getting hot that shouldn't be. It might be fine, but that might also be bad. Let's see if we have a reaction to the power button. We do. 2.3 amps. We are stuck at the DRAM LED, so this might actually be fine. 2.5 amps, yeah. Let me replug the DDR into a different slot. And it complains about RAM. Okay, yeah. So something with the RAM sockets is probably dirty. So what we can do is we can also take these cleaning sponges to clean out the RAM sockets a bit. So just take a good amount of IPA, and I try to get them as much as I can in between the slot and just clean them out. I will do that with both sides. And also what I like to do is just take a stick of DDR and just plug it in and out a couple of times for the contacts to get a little bit rubbed off of the dirt. And for this then to make a proper connection. So let's see now. Let's see at the power consumption once more. Still complaining about RAM. Okay. It might also be that the CPU isn't compatible. That is why it's complaining. Because then it can also complain like that. Let's try first another stick of RAM. If that doesn't work, I will have to take another CPU into here. Still complains about RAM. Let's take a different CPU then, just to be sure. We're gonna take a 3100. Pretty sure that should be supported in this board here. If that doesn't help, we might have to take a look at the DDR voltages that they all present, because that might also be a problem then. So let's turn this on. And this time we don't get a complaint instantly. Let's see. Do we have... yeah, we have switching power consumption. 3 amps, that looks very good. Oh yeah, I cannot... yeah, we don't have a display output because this is a 3100. It's now at the VGA LED. Yeah, and now it complains about missing video output. So let's get a GPU then into here. So it was probably only a case of the CPU not being supported. So let's plug a GPU into the first PCIe slot, get our post screen attached to that, and let's hit that again and see if we can get further. Let's also try 2 sticks of RAM in here then, because we didn't get stuck on RAM anymore. So we can see good amount of power consumption, 2.5 amps, 3 amps, that is very good. Let's see if we can get a post screen in here. What are you complaining about now? VGA, do you not like that GPU in there? Are you still going to complain? Or are you going to give me a picture? No, you're going to complain. Okay, let's take a different GPU then, because it's complaining about this one. This one has a problem with not supporting UEFI BIOSes, and yeah, sometimes it can give problems with that. So let's take a little bit of a newer GPU into here, and this might pass then. It will have a lot higher power consumption now, because this GPU just takes a lot of more juice than the other one that we had in here. So let's see now if we get a VGA LED again. So CPU turned off, VGA LED, and let's see, there is a picture, yeah. And we get a scrambled picture again because of the GPU that is in here. I have a weird way, like it does, the UEFI BIOSes don't like these old GPUs for capturing. Let's see now. We have a black screen, it's probably restarting by its own. Yeah, there's a picture again. Trying to get a proper picture. Yeah, and you can see the garbled picture of it being there 6 times. That is just because of the capturing of this. On my screen, I have a single picture of this board now, and it seems to be working fine. Yeah, let's turn this off. Let's get the interesting thing is now the passive power consumption also normalized. As you can see, we have 75 milliamps, which is quite normal. And now plugging in an M.2, and let's see for this board to go into Windows. So very good to see, almost 5 amps. That always tells us that the board is pretty much booting up. And there's a capture of a new screen. And we should see the reticle of Windows going around, that it is loading into Windows every second now. Rebooting on its own again. There we can see it. It's starting to go into Windows. And we have 2 sticks of RAM in here, which is very good. It recognizes the M.2, it recognizes the GPU, which is good. I have a keyboard attached there, so it also recognizes the USB. And let's also get Ethernet onto here to see that the Ethernet is working properly on this. Devices are being prepared right now. There's the Windows desktop, and you can see this can already spike pretty high. This is a 3100. This is a very low power CPU, and still with just a 75 watt GPU in here, we can spike up to 10 amps. We had that for a short second right there, just on startup without any stress testing, because the startup itself can be stress test enough in order to actually raise the power consumption a lot. So you can see like 7, 8, sometimes 10 amps in between there. That is normal for a booted up board, that can happen, especially if you have higher end components like bigger GPUs, or if you have higher end CPUs in there. This is, I think, a 65 watt CPU that really doesn't draw too much power. So yeah, and now we are in Windows, and Windows seems to be working fine, which is great to see. I do have both indications on my Ethernet, so that is also working. So yeah, we got pretty lucky on this one, I gotta say. I only checked that VPP area because I thought there was a short circuit, because I had the CPU plugged into there, which wasn't the case that was actually a short, but just me measuring a CPU resistance and thinking it was a normal resistance of the board. And then we got lucky and saw that 10 ohm resistor, which was cracked, which shows so much how important visual inspection is on ATX motherboards, especially because every device or electronics that has a bare PCB and components that can be accessed and users that interface with that, it can always have broken parts and damaged parts. Especially these small components can be so easily flung off as soon as someone is trying with a screwdriver or similar things in that area. They can just break so easily. You have small little cracks in them. In this case, it was a little bit more obvious, and especially in the areas around the cooler, people tend to break stuff all the time because they have to get in there with the screwdriver to get screws in, and they just slip very fast and think nothing has happened, and they have broken a component. And we have seen it time and time again that is all that is necessary in order for these boards to not work, because ATX motherboards very rarely die on themselves or have problems on themselves. Most of the problems are inflicted by the user, and in this case it showed it very well again. So, to the end of the video, I want to thank PCBWay once more for sponsoring our videos with great PCBs. Thank you so much to them. Thank you so much for listening and watching this video. All of my tools, as always, are linked in the video description. If you want to get a current sensing device or for your own, either check out my video that I have on measuring current of an ATX power supply of an ATX board, or message me on my email and you can buy one of these power meters. So thank you very much for watching. This was Mainboard Medic. Thank you very much and goodbye.